Hi gentlemen, this is page number 153. The question: what are the standards for safety valves? Answer: there are four major standards most widely practiced worldwide: ASME US, ISO International, BSI British, TRD German. Question: reliability is vital in overpressure protection programs. How does the valve design affect the reliability factor? Answer: large the number of components of a safety valve, higher is the probability of its failure. For instance, a simple spring-loaded safety valve contains about 18 major components. A high-performance spring-loaded valve for more demanding services has about 28 major components. An auxiliary assist SV may sport as many as 80 major components. When these three valves are put to comparison, an important point to note is that the auxiliary assisted valve will perform quite differently in the case any element of the auxiliary support system fails. The valve then will not perform within specified limits except to always fail in open position. Now, if each component in all the above three valve designs are 99.8% reliable, the probability of failure of the auxiliary assisted the probability of failure of the auxiliary assisted design is much higher than the other two designs because of the large number of components. Question: what is the functional difference between the spring-loaded safety valve and the auxiliary assisted safety valve? Answer: the spring-loaded safety valves performs independently, does not need any power source to operate. The auxiliary assisted design needs external power source to operate, and such there must be reductant power source to endow it comparatively reliability. Question: in general, only about 50% of all installed safety valves are capable of performing as per their initial specs, a fact that has been revealed in a recent industry survey. So, half of the installed population can have problems in varying degrees that may lead to valve failure. What are these problems that may invade valve failure? Answer: poor installation practice and/or improper operating conditions, adequate repair tools or lack of proper tools or equipments available on site, shortage of spare parts on site, spare parts not procured from the original valve manufacturer or any renowned company, improper trained technician, lack of proper test failures, facilities or techniques. Question: how can we guard against poor installation? Answer: poor installation usually detectable during startup and testing. It is always advised to follow the guidelines provided by the reputed valve suppliers to assure proper installation. Question: what operating conditions can impair the safety valve operation? Answer: operating pressure too close to valve set pressure, mechanical vibration, sonic vibration. These are the conditions can impair the valve safety valve operation. The next question: what is the usual effect of these adverse operating conditions? Valve leakages, premature valve opening. Question: how can you solve the lack of proper repair equipment on site? Answer: the easiest and safest way is to procure from the valve suppliers all equipment and tooling necessary for servicing their products. An alternative is to make them available from another source. Question: what should be the common philosophy in the management of service and repair of safety valves in power plants? Answer: the power plant should maintain the list of critical components identified by the valve suppliers, maintain an inventory of these critical parts necessary to keep their products in service, review the need for additional components as planning for future scheduled outage proceeds. Question: Suppose a power plant finds the order delivery load time for safety valve spare spots is too long. What are the alternatives left? Answer: the power plant has two alternatives. Either the power plant will attempt to rework the existing pots or it will try to have new pots fabricated locally. Question: what which one you deem preferable? None. Why? Neither alternative is acceptable. Question: do you think fabricating new parts locally is bad? Yes. Why? Answer: manufacture a part locally by copying the original equipment's manufacturers OEMs. Part invites the highest risk. How? Answer: most people do not have adequate depth in the technology associated with their good safety valve design. If improperly designed, a part may fail and that can lead to loss of overpressure protection. Wrong materials of construction. Material selection is not an arbitrary process. Highly specialized materials are necessary to carry seat loads, withstand impact loads, and take lapping to reduce leak paths. Corrosion resistant seals are frequently used, but they must be heat treated to exact specifications to attain proper hardness. Wrong gate material boats disaster. It can result in improper clearness. Under demanding service condition, thermal expansion may prevent the disc holder from sliding within the guide with the effect that wall lift is restricted and its capacity is reduced. Or the worst, the disc holder may get jammed inside the guide, arresting valve lift altogether during overpressure emergency. Poor dimensions. If the parts are not manufactured to exact dimensions, proper assembly of components is simply impossible. At higher service temperatures, this proper fit becomes the most vital criteria for as much as the wall components expand. The dimensioning of the part may be lead to either valve leakage or stuck up of disc holder in the guide. Poor SV performance because of use of parts not of OEM quality entails possible loss of plant safety. Question: why is the quality of personal training a no less important factor in determining the safety valve's performance? Answer: improperly trained personnel will end up with the improper installation of the parts, even if the quality parts are not hand hand. Defective installation degrades valve performance and tells upon safety. The valve will start leaking at the very startup, and if during the installation of the parts the proper sequence is not maintained, allowance for movement of parts could be incorrect, leading to binding. Question: after the installation of the proper parts, the SV is subjected to testing. How will you be assured of correct alignment of components parts in the valve? Answer: the valve set pressure, if the component alignments are okay, repeatable will be stable and repeatable. The question: what is the purpose of seat tightness test? Answer: to get sure that the seat conditioning is successful and that the valve can remain leak tight while normally closed. Question: during valve testing, determination of the valve's full lift and closure pressure is very difficult. Why? Answer: this is because the valves are tested on test facilities that produce only a small percentage of valve rated relieving capacity. Question: what should be done to determine the valve's full lift and closing pressure? Answer: the valves must be mounted on the boiler and put to overpressure test. This system is preferable and rather more practical as it will allow a check on all performance parameters. Question: if the overpressure on the boiler is not allowed, how will overpressure testing be done? Answer: overpressure only the drum and superheater, assuming that this is permissible. An auxiliary setting device for serves an auxiliary setting device serves for the reheat, permitting verification of set pressure and leak tightness. If overpressure of the drum and superheater is not allowed, the auxiliary setting device can also test the drum and superheater service. The valve should be adequate 3 times, recording data in each time. This way one can assure stable set pressure. At the test end, a final leak pressure test is to be conducted with no leakage permitted. When the boiler is back in service and operating under stable conditions, the SV set pressure are again to be tested by the auxiliary setting device. The check assures correct valve opening pressure. Thank you.